Okay. What we're going to do is work on creating equations from problems. So we've been given this word problem here. We're going to read through it. And usually when I go through a word problem, I read through it once, and then the second time I try to like highlight important information. So I usually read through it minimum 2 times because it can be hard to pull all the information out of like a paragraph. So we're going to read through it together here. So Dave has 5 baseball cards and 4 hockey cards. Thomas has the same number of total cards. Thomas has 6 hockey cards. Create an equation to represent this relationship. How many baseball cards does Thomas have? So, that was a lot of info. So I'm going to go through it here and we're going to try to pick out some interesting stuff. So, first of all, how many people are in this?
2.
There's 2. There's a guy named Dave, right? And there's a guy named Thomas. And what do they collect? Cards, great. Great. So there's baseball cards. We have that. And look, here's another thing that says baseball cards. And hockey cards. Hockey cards, okay. Now, there's something special about it. Does anyone have more cards than the other guy?
No.
No. In fact, what is it? They have the same amount?
Yeah.
Great. So that's going to be really important to us. So, I'm going to highlight a little more. It does tell us how many baseball cards Dave has. He has
5.
Exactly. And how many hockey cards 4. He has. Great. How many hockey cards does Thomas have?
6.
6. Great. And baseball cards?
He has the same.
We don't know. It doesn't tell us in this question. But we know he has the same total number of cards. So that's going to be important to figure out. So this question's actually asked us 2 different things. I'm going to pull out another color here. Yeah, great, purple. It's asked us to create an equation, and then it's asked us to solve here how many baseball cards does Thomas have. So we're going to do 2 different things, okay? So what I'm going to do is, let's start with this. We have Dave. Here's good old Dave. Hi, you. You look good. Here's good old Dave, and here is Thomas. Very similar looking people. Thomas is going to have a baseball hat, okay? Just so we can tell the difference, right? So we got Thomas here, and we got Dave here. And how many baseball cards does Dave have?
He has 5.
Great. So he's got 5. So I'm just going to put them in green here. We'll represent them in green. So there's 1, 2, 3, 4, 5. And how about hockey cards? How many hockey cards does Dave have?
He has 4.
4, great. So 1, 2, 3, 4. And what about Thomas? Do we know how many baseball cards he has?
No.
No, so I'm going to put a question mark for green. We don't know how many he has. And what about hockey cards?
He has 6.
6, great. So it's always nice to make visuals of stuff, and then we can start to create our numbers that represent things. 1, 2, 3, 4, 5, 6. Great. Now, what do they tell us? What's special about the relationship between the 2? Does anyone have more than the other?
No.
No. So they have the same amount. Do you know what we usually use in math to represent something that's the same? There's a symbol for it. Yeah, equal sign. So we're going to say Dave. Oh, okay. Did we do that? Dave is equal to Thomas. This is great. And instead of having our drawings, let's start representing them as numbers, right? So we had 5 of those and 4 of those. So how many cards did Dave have in total? Do we know?
He has 4. 9.
9,
Sorry.
great. That's okay. 4. He's got 9 cards total. That's really good to know. That also, since we know that Thomas has the same amount, we know that if we add, he also has 9. So that's really good. Again, we don't know how many baseball cards he has, but we do know he has 6 hockey cards. So this is good. We've started to create some stuff. What we're going to do next... Oops, can I shrink this? Okay, I was hoping to shrink more. We're going to build an equation. So we've actually already started to build it. It just doesn't look the way the equation writes. We're going to write this all horizontally. And we're going to have an equal sign between them. Okay? And we know that Dave is going to kind of be here on the left. And Thomas is going to be here on the right. And instead of putting it vertically like when we add 5 plus 4 equals 9, we're just going to write it here. 5 plus 4. Now we're not going to say equals 9. We are going to say is Dave is equal to Thomas. Because we already know it is 9, right? On the other side, Yes, we already. That's great. You've already figured out the answer. But we have to build. The first thing asked us to create an equation, so we still have to do that.
Yeah.
So 6 represented how many hockey cards he had.
3.
Great. So we know it's 3. But let's say we hadn't figured out the answer. How can we represent something that we're not sure of in math? Do you know what you use? If we don't know the number, they're asking us for something that's unknown.
No.
A lot of times they'll use a letter. They'll call it like a variable. You could
yeah.
use a letter, maybe N represents
A.
like number, A, B, C. All of those work fine. What letter do you want to use today? Doesn't matter.
Z.
Sure. So Z is going to represent baseball cards. A good letter sometimes in math, sometimes we associate the letter with what it is we're missing. So if we're missing baseball cards, like a B could work, a C could work, but a Z does the exact same thing. It doesn't really matter. So we have this here, and we know intuitively very quickly, okay, we know they both add up to 9, so Z must be 9. But there's another way we can figure out this equation, and that's just like the game you've been working on. Okay? What we're actually going to try to do here is we're going to isolate this letter Z. Okay, so we have an equal sign, and I want you to think of that, and I know they don't really go over this at this point in school for you, but we're going to think of this as the middle. Okay, so the middle of the equation. So Dave is actually on the left side. Okay, I'm going to call it LS for left side. And Thomas is on the right side of the equation. We need Z to be by itself. And since it's already on the right side of the equation, we're going to leave it there. I'm going to leave Z by itself. So what else is on the right side of this equation right now? 6. We need to move it to the other side. Technically, it's not just 6. It's technically positive 6, but we don't write it in. It's not. We just assume everything's positive if there's nothing in front of it. If I want to move it to the other side, I have to give it its opposite operation. So I'm going to move 6 all the way over here.
And put the 5 there.
Nope, we're going to leave the 5 because remember we want Z by itself. What's the opposite of positive?
Negative.
Negative. So it's going to become -6. And then I'll write like a plus sign here. So let's rewrite what we got here. We got -6 plus 5 plus 4 is equal to Z. Okay? Z is the number of baseball cards. Now we got to put together these integers. It's a little tougher. -6 and +5. Do you know what that is off the top of your head?
-6
And
plus
positive, yeah, plus 5.
5.
We can make a number line.
Sure.
Yeah, okay. So we're going to start at -6, right?
Would it be 1?
Close.
0?
Let's do the number line. You're very close. 2, 1, 0, 1. Oh man, I'm running out of room. Okay. When we do integers, what we can do is we can start at a value. So we have -6, right?
Yeah.
And then it says positive side. Well, positive on a number line is usually written to the right, and negative, okay, is like moving to the left. So since we're going +5, we're going to move to the right 5 position. So I'm going to jump. 1, 2, 3, 4, 5. What number did I end up at here?
-1.
-1. Very good. So let's shrink this a little again. So these two numbers together, they create -1. But we still have +4 is equal to Z. Okay. Let's do a number line again. This time, what number are we going to start at?
-1.
-1. In which direction are we going to go? Right or left?
Right.
Right. So since we know we're going to the right, I can put -1 all the way to the left. I only need to represent numbers to the right because numbers to the left are not going to be important. So after -1, if we're going up, we go 0, 1, 2, 3, 4, 5. Hopefully that's enough, right? Let's do the same idea. We're going to start at -1. And how many positions are we going to go?
4.
4. And in which direction?
Right.
Right. So we go 1, 2, 3, 4. What number did we get?
3.
3. So you intuitively got this really quickly. You knew it was 3, right?
Mm-hmm.
But this is a way they call it algebraically to solve something. Okay, it's really good if we can actually start to make equations like that. That's the purpose that they wanted you to create an equation, is so you can start to just manipulate it. Because sometimes you're going to work with numbers that you're mentally not going to be able to solve right away. But if you know these rules about switching sides of equations, it's very, very helpful. Okay, so